Hello students, in this session we will discuss about two enhanced data models like spatial databases and multimedia databases. So generally we will discuss about the basic concepts behind the spatial databases and the multimedia databases. So here first of all we will discuss about spatial databases. What do you mean by spatial databases? So, as you all know, the term spatial indicates it is a two-dimensional location, or it is a space-related data. Means when we look into the surrounding world, that means when we look into the ground, or when we look into the roads, or when we look into the rivers and all, how the data corresponding to those areas can be represented. So one of the major example of having this spatial database is the formation of maps. So you will be very familiar with map, how we are representing the data in map. So it is actually based on the concept of spatial databases. So initially we will look into the basic concepts of spatial databases. So what is happening with spatial database is it keep track of all the objects in a multi-dimensional space. It will keep track of all the objects. So first thing is the spatial databases store the data in object format, and the object which is not in a single dimensional, it is actually represented in a two or more than two-dimensional space. That will take either 2 dimension, or maybe it will be taking 3 dimension or more than that number of dimensions. So for example, if we see one building on a location, the corresponding 3D or multi-dimensional representation of that particular data. So when we represent a map for a village, or when we represent a map for a panchayat, so there will be a number of buildings available, multi-stored buildings available. We'll be having some rivers available, we'll be having some roads available. Then similarly many objects are available. So how we can represent all these objects? So as we require all these data for representation, especially in the case of map representation, we require all these types of data representation. So it is an enhanced database model where we can represent such type of spatial data in a better way. So basically spatial databases are actually some objects, some real-time objects that is being represented in a multi-dimensional space. So some of the examples of the usages of multi-dimensional or spatial database is, first one is for the representation of various maps, because all the maps consist of the representation of different objects in different formats. So if you look into a map of a country, you can see the objects are represented in different way. If it is a two-dimensional map, it is represented by using different colors, different lines, different shapes, etc., etc. Similarly, we can also have multiple dimensional representation of these data in different formats of maps. So basically we are using two-dimensional maps where we are using some shapes and colors for representing different objects. Then the second usage of spatial database is in the area of geographical information systems. Geographical information system is actually the weather-like information, how geographically a particular location that can be represented, or what are the variations that happens on. So if you see the news channels and all, you can see the weather updates. There will be changes in weather, there will be chances of rain, there will be chances of a small rain, there is means a sunny day, etc., etc. all these are changing for the same object, or the representation of that object will be represented in a different way, so that all the informations regarding the geographical changes can be represented, and that can be changed dynamically by using the geographical information system. So such type of weather updates and similar and several terrain and other mountains or rivers, etc. For all these informations and representation of those informations can be done by using geographical information system. So especially this system is given as a separate mode, because we are usually using nowadays, we are using Google Map for finding a particular route and all. So it is actually based on the geographical representation of that path. So if you are going into one particular destination, we are using a system called as GPS. So GPS is an example of geographical information system, where we are following a particular path based on especially based on the shortest path for reaching that particular destination. So that situation, we require all the informations related to that geographical area. And the third usage is weather, that I have already mentioned. It is slightly related to the previous concept, that is geographical information system. That means for different weather updates, for representation of weather conditions, whether it is sunny, whether it is a rainy day, whether it is a light rain or light thunder shower, etc., etc. All these can be represented by using the spatial database model. So the representation will be different. Maybe it is in a single dimensional or two dimensional, or maybe in a more than three dimensional format. So in general, we can call a spatial database are or they are in n dimensional format. So we cannot say that the entire objects will be in two dimensional, or we cannot say that all the objects in the map will be in two dimensional or three dimensional. So some of the objects may be three dimensional, some of the object may be more than three dimensions, some of the objects may be two dimension, etc. So it is depending on the objects available in that particular system. So now in this particular subject, we will be focusing only on two-dimensional spatial databases. So for these types of representation, multiple dimensional representation, we need to have some modification on the data models. So one of the major type of spatial databases that we are following is two-dimensional spatial databases, which are used for mainly for representing different maps like structures. Now we will look into the different spatial data types and the different models followed in spatial databases. So the different data types that we are following with spatial databases are given below. So first one is map data. The primary type of data type that we are following with spatial database is map data. So what are the contents, or what data can be represented by using map? That is, it includes various geographic or spatial features of the different objects present in a map. So a map data includes various geographic or spatial features of objects in a map. For example, a river is actually flowing in one way from east to west. So what are the features of that particular river? How we can represent that particular river? It is depending on the feature, geographic feature, like it is having two lines and we need to represent the river flow by using a particular color, and also it is depending on the spatial features of the given object. So if you represent a building, so a multi-stored building will be having a different representation. It is having its own geographic location and its spatial feature, how it is being represented. So we are mainly considering the shape of the object. Maybe it is following a rectangle shape, maybe it is following a line shape, or maybe it is following some other, maybe some circle shape, etc. So depends on that we will decide the different data that is part of map data, which is used for representing a spatial database. So it is depending on the object's shape and also the location of the object where it is being represented in a map. So we need to consider the shape of the object and also the location in which, for example, near to a particular building we are having a river, or near to a particular building we are having a road. So all these can be represented by using different shapes and also in which location that object is being represented. Now some of the features that can be represented for this map data. So what are these spatial features? We will see the three basic types of features of map data which is followed in spatial databases. They are, first one is the different points, the different lines and polygons for representing different shapes. So three basic types of features that can be represented by using a map data in the case of spatial databases. So first one is the points. So points are used to represent spatial characteristics of objects whose locations correspond to a single 2D coordinate. So if you take a particular map, now assume that I am representing this as a point. This is a point. So this is the representation of a particular object. So one object is present here as a point, and this is on some location that is in the x and y coordinate on a particular location. For x one value, for y one value, one particular location we are having an object is being placed. So in 2D coordinate we will be having some points. So here we are having an office, here we will be having one building, here we are having one ground. So something like that, we will be having different points that can be represented in a particular map. So it is corresponding to the objects. So different objects, individual objects can be represented by using, so some of the objects can be represented by using a single point. So some of the examples of point representations in the case of map data is buildings. So various buildings can be represented by using points. Then cellular towers, mobile towers can be represented by using a single, because it is stationary, it is not moving, like building is not moving. So cellular tower is not moving. Okay, so this is also represented by using a point. Similarly, stationary vehicles. Stationary vehicles means a vehicle which is standing. That means it is being parked here. One vehicle is parking there. Now, as it is not moving, it can be represented as a point object. But if it is moving, it is a different type of data. So in the map data, some of the features are points, lines and polygons. First feature that we are representing by using this map data is point, and these points are represented for the objects whose locations are not being changed. It is fixed in a 2D coordinate. Examples are buildings, cellular towers and stationary vehicles. Similarly, many objects can be represented within a particular map that is not moved, or we can call it as a stationary object. Now the second feature that we are going to represent by using map data is lines, different line representations. So which all data are represented by using lines? So lines represent the different objects having some length. So as I was mentioning before, a river will be having some length. It is not of a single area. river cannot be represented as a point object. So it will be the connected points, we can call it as a connected point that forms a line which is having some length. So we can represent some roads or rivers whose spatial characteristics can be approximated by a sequence of connected lines. So a river with 200 kilometers long, so different lines are being connected. So this object will be formed by connecting different number of lines. Similarly, some roads, for example, MC road is of some 300 kilometers. It can be represented by connecting different number of lines together in the spatial or map database. So the second feature that can be represented by using spatial database and especially with map data is line. So point objects, line objects, and third one is different polygon objects, or the feature that can be represented by using polygon. So polygon means a shape with multiple number of coordinates. So these are used to represent spatial characteristics of objects that have a boundary. So a single building can be represented by using a point data, but for representing a country we need to have a shape. So polygon, we are using the model that is called as the feature model that is called as polygon to represent a particular country, or for representing a state or a lake or a large city. All these can be represented by using different shapes. So we cannot say that. So as you know, India is having a particular shape in, so it is a polygon, means we cannot exactly say the shape, but it is with multiple number of coordinates. I mean different means the shape will be different, not about the coordinate. We are discussing only about 2D. So polygons will be having different sides. So we cannot exactly say that how many sides it is having. We cannot say that it is a triangle. We cannot say that it is a rectangle. So normally these countries, states, lakes or cities etc. can be represented by using the different polygon shape. So this is very important. So three different features that can be represented by the map data or map data type which is used with spatial databases are points, lines and polygons. Points simply for representing stationary objects like buildings, towers etc. Lines are used to represent an object with some length like roads or rivers. Polygons for representing some objects with some boundary like countries, states, cities etc. Now second data type that we are following with spatial databases are attribute data. So previously we were discussing about map data with its features. Now we are going to represent attribute data. So what is attribute data? So it is actually the descriptive data that a GIS systems associate with map features. Some descriptive data, that means some explanations regarding an object that is present in the map. So we are representing map objects by using either line, polygon or points. Now we need to provide some description on that particular area. For example, if you look into a country, inside the map we are having a country, and there will be some description like this country, the population of that country is this much, the total capacity, population of that country. All these things are available within as a description of that particular shape. So we are representing an attribute data that is for giving further description to the data that are represented by using a GIS system. It is being associated with the features of map. So for each of the map object we are trying to represent this attribute data. So attribute data gives some description on the data that are represented within that particular object. So we will see some examples. Suppose a map contains features that represent counties within a US state. So as you know, US state is again divided into a number of counties. So like India is divided into a number of states. US state is divided into a number of counties. So the different features of each counties can be represented by using this attribute data. Like one of the county name is Texas, another county name is Oregon. So these description or features of that particular country can be so like in a relational database we are having different rows available, and the description of that rows are given as the attribute. Similarly, for each of the object we should have some description what that particular object represents. It is by using the attribute data. So we need to give further description on the objects that are represented within spatial databases. Now attributes for each county feature or object could include like population that I was mentioning before, then which is the largest city or town, and area in square miles, how much or what is the area of that particular county, and similar information. So if you look into the map of India, if you look into a large map which is available in reality, there you can see that we are not only representing a country and its locations, it will be giving some additional information about that particular state. For example, inside India, if you take one particular state, Kerala, we can see the description of that particular state also. So that additional data, in order to give further description on that object, is actually represented by using the second data type, that is called as attribute data. So other attribute data could be included for other features in the map, such as the different states, different cities, congressional districts. So it is actually based on some other countries. Then what is the census of different, how many males are there, how many females are there, how many children are there, etc., etc. All these informations can be. So when we look into the map, we are not only looking to the location of that particular object, we are also looking for getting some additional informations regarding that particular object. So for that particular purpose we are using an attribute data. Then third one is, so we have seen map data as the first data model, data type, second one attribute data, and now we are going to discuss about image data. So third data type that is used with map data or spatial database is image data. So this image data includes the data such as satellite images. So if you see the Google map, we are actually getting the satellite images. So how it is being represented, from the satellite they are actually taking the image in reality. So exactly they are using the same image that is being taken from the satellite. So satellite images, there you can see the exact picture for a building, for a ground, for rivers, roads, etc., etc. We can see that exact image. Okay, so one of the example for image data is the images taken from the satellite. Similarly, aerial photographs, that means the photographs taken from aerial means from aeroplane and all. We can take some photograph from top, aerial. Like nowadays we are using drones for taking photographs. It is an example for aerial photograph, from some top location we are taking the photograph of our area, our location. So that image that is taken from these photographs can also be used for representing a particular map. So these images are actually created, as you know, it is created by using different cameras. So camera will capture the image and image will be used for representing some portions of the map. So in reality, in Google Map and all, we are using these image data for representing the map information. Now, objects of interest such as buildings, roads can be identified and overlaid on these images. So by looking into these images, even you can see your home by checking the Google Map using that satellite image that is already taken and stored in the server of the Google Map. Now these images can also be attributes of map features. So it will also consist of some features. So image will also have, like the satellite image that is being taken will also be having the other informations, like other features of that particular locations from where the image is being taken. So we can represent the attributes also along with the images that are taken as the data for the map. Now one can add images to other map features, so that clicking on the feature would display the image. So when we create a map, we will be having different countries. For example, this is a country. Now if you click on this particular feature, we will be having different representation, different features can be represented within that map. So we can add some image along with that, and if you click on that particular location, it will display whatever is required for that. For example, if you are having the map of India, and if you are having a link for each state, so each state, if you are having some satellite image data, and if you click on this particular area, the information for that particular area will be displayed. So whatever details are given there, that will be displayed, so that the user can easily identify or understand the details of that particular country. Now aerial and satellite images are typical examples of raster data, which is actually the data, special type of data, image data, that is represented in the image processing concept of computer science and engineering field. So this is actually an example of raster data. So raster data is used for representing images, generally aerial and satellite images, for representing the different map informations for the spatial databases that we are following. So we have seen three types of data types that are followed in spatial databases. First one is map data, second one is attribute data, and third one is image data. So these different data types are having different purposes. Once again, map data for representing different objects, how it is being represented. Second one, attribute data, what are the features of those objects that are represented by the different map data. And the third one is image data. For representing map, we can use the still images that are taken from camera, either from satellite images, or that is directly taken from some camera that is used as an aerial camera. All these can also be added into the map, so that we can represent some additional information about a particular map. So these three are the data types followed in spatial databases in general. Now next one is spatial queries, the different spatial queries. So we are not going to discuss in detail about how to represent all these queries, but generally for this particular emerging data model, generally we are discussing about the models, the data types that we are following, and what are the types of queries that can be used, because we need to associate this spatial database concept with our real-time relational database concept. So how it is being related to normal databases. So in that way we are discussing about the different types of spatial queries that can be applied to the spatial databases. So some of the queries are range query, nearest neighbor query, and spatial joins or overlays. So you will just see what are the differences between these types of queries. So range query, you might be knowing range query. In relational database also we are using range query to retrieve some informations between two ranges. So here also we can get some informations from the map based on this range query. So for example, for finding the objects of a particular type within a particular distance from a given location. For example, this is one location, location 1, and this is location 2. Find out all the hotels between these two locations. It is called as a range query. So the range is actually between two objects. Okay, so find out all the hotels between location 1 and location 2. So a range must be specified, or we can call find out all the hospitals between location 1 and location 2. Okay, so here from the textbook I have taken one example like Taco Bell's in Pleasanton. Pleasanton is a location, so it is having boundary. So Taco Bell's, I don't know exactly what is that, but what are the different, we take hospitals within a particular location. So there is a boundary, there is a range. Okay, so that is actually called as range query. Now next one is nearest neighbor query. Nearest neighbor query. Nearest neighbor query, which will find, as the name indicates, it will find the nearest objects. Find objects of a particular type that is nearest to a given location. So we are not setting a boundary. So when we are making a long travel, and if we want to find out all the nearest hotels, okay, in surroundings, so it will find out all the hotels near that particular location that where we are standing. So all these are possible with Google Maps and all. So nearest neighbor. So range query means we are having a boundary, but nearest neighbor means wherever I am standing, current location, and I need to find out all the nearest. So if you are trying to get an admission in a college, so just search in Google nearest colleges. So it will get all the colleges surrounding your means it will take the most closer colleges nearer to your location. So for that particular purpose we are using nearest neighbor query. So nearest Taco Bell from an address in Pleasanton. So nearest hospitals or nearest hotel from the current location where we are standing. So current location or some particular location. So that is the second type of spatial query. Now third one is spatial joins or overlays. Another query that is being followed. Spatial joins. So this join is important. It is given another name called as overlays. It joins objects, more than one objects of different types based on some spatial condition. So different objects can be joined based on some condition. So like intersecting, two objects are intersecting, or overlapping within a certain distance. So what example we can say? For example, there is a river going in this way. This is a river. Now assume that there is a flyover road arrives here. A road is going this way. So this is a bridge. So we can see these two are connected. Okay, maybe we can call it as intersecting. One portion of road and one portion of river, they are connected. For that particular, that means all the, for example, this is a long river. This is a long river. All the bridges connected to that particular river. So it joins objects of two different types based on some spatial condition. Okay, so all Taco Bells within 2 miles from IC 680. So here all the bridges within some kilometers of a particular river. So two different objects. So one is a river. So here in this particular case, this is actually of a similar type, because river is represented by using connected lines, road is also represented by using connected lines. Maybe some other objects. Maybe if you take a road side, will be having buildings. All the buildings will be having a different object. Okay, so spatial joints connects more than one objects of different types based on some conditions. So three different spatial queries that are generally followed by spatial databases are: range query to find out the objects between two ranges, nearest neighbor query to find out all the objects near to one particular location, and spatial joins all the objects that are overlapped or intersected to a second object. Now the representation of spatial trees can be internally done by using different tree structures. We will just look into that. We are not going in detail on that. First one is spatial representation by using R trees. R tree is a data structure. So it is a technique for typical spatial queries. For representing spatial queries, we are using R trees. It group objects close to spatial proximity on the same leaf node of a tree structure node. So if this is a tree, so it will group all the objects on a particular leaf node. Group objects close in spatial proximity. For example, all the buildings on a particular village. So it will be part of the same leaf. In this way, that will be represented in the case of R trees. That means the objects that are closer in spatial proximity, which are closer. So which object will be part of that particular leaf? So all the so assume that this is the panchayat, and all the buildings within that panchayat will be attached to that particular leaf. Now internal nodes define areas, that is rectangles that cover all areas in the rectangles in its subtree. So internal nodes define areas that cover all areas on the rectangles in its subtree. So the internal nodes represents the spatially closer objects together and within a particular leaf. So similarly, some other leaf, there they will be having several objects that is being connected, which are closer to that particular area. So this is the representation in R trees. Now another representation is chord trees. In chord trees, it divides subspaces into equally sized areas. So now R tree means different objects, group of objects will be having different sizes. So here we are having some 4 buildings available, here we are having some 10 buildings available, here we are having some 100 buildings available. Depending on that, these nodes will be or that area will be larger or smaller. But chord trees, what is happening is it will equally divide. This area, it will equally divide the different number of objects into a fixed sized areas. So if this is the map, so different portions can be separated of equally sized, so that every size, for maybe some objects are here, maybe the number will be different, some object number will be different, but they are having equal size. So within that particular size area, some objects will be available. So that is the difference of chord trees with R trees. So that is all about spatial databases. So in this subject, for this particular enhanced data model, spatial databases, we were discussing about the basics about what is spatial databases and how it is different from normal databases. Then what are the different data models or data types that we are followed in spatial databases that we have seen. Then we have seen the different data types. We have seen the different data types like map data, attribute data and image data. Then we have seen different spatial queries like range query, nearest neighbor query and spatial joins, and we have also seen some of the representation of spatial databases by using some of the data structure formats. Now we will discuss about multimedia databases, which is another emerging or enhanced data model which are supported by various DBMS system. So as you know, multimedia databases are having more importance nowadays, because nowadays we are representing huge amount of multimedia data in that is through the network and all. Means, for example, all of you are accessing YouTube contents where we are having multimedia informations like music, videos, etc. All these are represented, which is of larger size. The main problem with this multimedia databases is the objects are of larger size. So how we can manage these large data, or how we can represent these large data by using a multimedia database system. So nowadays, as you know, in the textbook it was given like in the years ahead, multimedia information systems are expected to dominate our daily lives. But now currently this is that is already being dominated in our daily lives, as all of you are familiar. Now they are expecting like all the houses will be wired for bandwidth to handle interactive multimedia applications. Nowadays we are getting television system with all the interactive support, like we can directly interact with the system. Whichever video you want to play now, that can be played. Whichever music you want to play, that can be played directly by live interaction with the system. That is already possible with many DTH platforms. So that is so huge data must be there in the server. So like our HD TV or computer workstations will have access to a large number of databases, including digital libraries, images, video databases, or similar multimedia components. So high definition data or video will be having more capacity. It requires more memory. So storage of this huge memory is the main risk with the multimedia database systems. So we will just look into the different types of multimedia data available in our day-to-day systems. First one is the text data. Text data may be formatted or unformatted. Formatted text or unformatted text. That means for ease of parsing structured documents, standards like SGML and variations such as HTML are being used. So normal text, formatted text and unformatted text. So what is the difference? So normal text, a PDF document can be considered as a text document. Similarly, a document that is being represented by using some HTML web design model. So one is formatted and second one is unformatted. That means if you are using some HTML and all, we can say that the text is being formatted by using the support of standard generalized markup language or HTML, so that the text can be displayed in a proper format. So whenever we are accessing some particular website, we will be having different types of text that will be displayed there. So formation of these text, representation of these text, and managing huge amount of text data is actually coming under the category of storing multimedia data. So the basic data that we are followed in multimedia databases are text data. Then second one is graphics data. Example includes like different drawings or illustrations that are encoded using some standards like CGM, PICT or PostScript. By using some standards, different drawings done by using different tools different computer tools, different graphic designs, that are actually a second category of multimedia data. Special categories of graphics, the drawing done by some particular tools. Then third type of multimedia data is images. We are using more number of images. It includes drawings, photographs and so forth, encoded in standard formats such as normal BMP, JPEG or MPEG. Now as you know, compression is built into JPEG and MPEG. They are actually compressed. So these images are not subdivided into components, hence scoring them by content. For example, find all images containing circles is not always true. So as you know, even recently only there was research like we can have a search on the image. Previously it was not possible with Google. If you give an image, whether the corresponding image can be searched. So normally it is not possible, it was not possible with the features of images. So now, but nowadays there are researches happening where we can identify something else from the given image, but earlier it was not possible for searching for a particular type of image. So image features are nowadays considered. Now images includes JPEG, MPEG also. MPEG is moving picture, so it comes under video. So images generally consist of still image as well as moving image. So the representation by using some particular format, which is generally followed with various images and videos. Then another type of multimedia data is animation data. These are actually sequences of image or some graphic data. So different drawings are moved in a particular given speed. So that is actually represented by using animation data. For producing different cartoons and similar things, we are using animation data. Then another multimedia data that we are following is that is video. It is again a set of temporarily sequenced photographic data which is under some movement for presentation at specified rates, like 30 frames per second if different frames are moving, and 30 frames per second if you are moving 30 frames in a given second, there will be some movement to that particular image. So it will actually convert it into video. So video data are very important. It usually takes more space to store, because even 1 second video consists of 30 frames. So normally for 1 minute the number of frames will be increased. Similarly for 1 hour, you can imagine the number of frames that are to be stored. Then another data type that we are following in multimedia database is structured audio. Structured audio is a sequence of audio components comprising of note, tone, duration and so forth. Especially music composers or music directors are following this type of structured audio with components like note. We are not if we are singing, we are not following all these aspects, but for structured audio they are following the different notes, tones and the duration, etc. For editing, audio editing and all, they are following these components. Then normal audio, another multimedia data, sample data generated from oral recordings, normal recordings, and that is being saved in a string of bits in digitized form. So if you are making a recording in your mobile phone, or if you are making a recording using your microphone and some other recording device, so these are actually analog recordings. They are typically converted into digital form before the storage. So by using microphone, we are actually getting analog data. It will be converted into digital format later. Then finally we are having one more type of data, that is composite or mixed multimedia data. Composite or mixed data, where a combination of multimedia data types such as audios and videos, which may be physically mixed and it will be stored in a new storage format, or logically mixed while retaining original types and formats. So audio and video mixing, you are aware about that. Normally video editors, movie editors, they are be having separate sounds available, separate videos available. They are doing mixing of these two types of datas. Video is having one type format, audio is having another type format, and then when they are mixing these two, we have to consider some factors. So that is an additional task that is to be done for this composite or mixed type of multimedia data. Composite type data also contains additional control information that describes how the information should be rendered for the retrieval. So composite data also contains all the additional informations for dealing with that particular composite or mixed data. Now, the nature of multimedia applications. Now, multimedia data may be stored, delivered, and utilized in many different ways. Multimedia data like music, video, all these can be stored in different formats. We can use different ways for storing this, and for transferring this video. Even nowadays we are using different formats, and different methods are followed for delivering all these multimedia data. And the utilization is also by we are using different tools for utilizing all these videos and musics. All can be done in various ways. Maybe, and also applications may be categorized based on their the data management characteristics. So these multimedia applications can be categorized based on the data management characteristics. It depends on whether it is only required for video category, it can be categorized in that format, or if it is used only for audio, or it is only used for text purpose, based on that it can be categorized. So that is all about multimedia databases. So generally we are only having general overview on multimedia databases. What is multimedia databases, the importance of that, where we are following that, then the different types of multimedia data that are available and that are to be stored as part of multimedia databases, like text, graphics, images, animations, video, structured audio, normal audio, and composite or mixed multimedia data. So that is all for now. So we have seen today about two emerging or enhanced data models in database, like the spatial databases and multimedia databases. So that's it for now. Thank you.